deliver the lecture on the basic concepts of trigonometric functions by matrix. The overview of this lecture is that I am going to represent various trigonometric functions, their domains and range, as well as their graphs along with their periods. First of all, I am going to discuss the sine functions. The sine functions are basically represented as y is equals to sine of x. The domain of such functions include the set of all real numbers. The domain is actually the value if we can put in the functions, then the value of that function is not inconsistent. So the sine functions gives the unique value on all the numbers of the real lines. So the domain of such functions include all the numbers from minus infinity up to positive infinity. Its domain is the set of all real numbers. While on the other hand, the range of such functions include the real numbers from -1 up to +1. Note that I have used the square brackets. It means that -1 and +1s are also included in the set. I have also graphically represented the range on the number line. The range shows that its value is from -1 up to +1. It is important to know that the value of sine function is positive only in first and second quadrant. So all the values from 0 up to +1 are all the values from 0 up to +1 we can get if we put values of sine from 0 up to 180. While on the other hand, the value of sine function is negative in third and fourth quadrant. So we put any angle from the third and fourth quadrant, it gives a value of negative, and its values from 0 to -1. The negative maximum value of sine functions occurs at 270 degree and it is -1, while the positive maximum value of sine functions occur at 90 degree and it is +1. The minimum value of sine functions occur at 0 degree, 180 degree, 360 degree and so on, and its value is 0. Now I have represented the graphs of sine functions. If we put x is equals to 0, then the value of sine functions will be 0. Similarly, if we put x is equals to 30 degree, 60 degree, 90 degree, then the values of sine functions will be 0.5, 0.86 and 1 respectively. I have plotted the graph between the values of x and the sine functions. We can say that the graph of sine function is the sinusoidal and it passes through the origin. The one important hint to remember the graph of sine function is that it passes through the origin. Origin is actually basically the point where both x and y axis intersect each other. We can see that the graph of sine function passes through the origin, so we can easily remember that it is a graph of sine functions. Moreover, I have also discussed the concept of period. In this lecture, the period of any trigonometric functions is actually the smallest positive number which, when added to the circular measure of the angle, gives the same value of the functions. Many students are confused of the concept of period, so I have demonstrated its concept from the example that we get the same values of sine function if we put sine x and sine x plus 2 pi. So we can say that the values of sine function is 2 pi. Moreover, we can also make it clear that if we put sine x and sine 390 degree, then we get the same value. So we can say that the period of sine function is 2 pi. Different trigonometric functions have different periods which are discussed in this lecture. The second type of function include the cosine function. These cosine functions are represented as y is equals to cos of x. This cos is actually the coterminal of the sine function, so it is also said that cosine x. The domain of such functions also include the set of all real numbers. We can get unique values of cos function if we put any values from the set of the real numbers, while the range of such functions is also from -1 up to +1 from like the sine functions. Here the square brackets also indicate that -1 and +1 are also included in the set. The graphical representation of the range of cosine functions in the number line is shown below. It shows that its value is from -1 up to +1. It is important to note that cosine function is positive only in first and fourth quadrant. So we get all the values from 0 up to 1 if we put any angle from the first and fourth quadrant, while on the other hand the values of cosine function is negative in second and third quadrant. So if we put any value of the angle from second and third quadrant, then the value of cosine function will be from 0 up to -1. The value of cosine function is maximum is maximum positive at 0 degree and it is 1, and it is maximum negative at 180 degree and it is -1, while the values of cosine function is minimum, which is 0 at 90 degree, 270 degree, and so on. Okay, now I have represented the graph of cosine functions. If we put x is equals to 0, then the value of cosine function will be 1, which is its positive maximum value. Similarly, if we put x is equals to 30 degree, 60 degree, or 90 degree, then the values of cosine function will be 0.86, 0.5, and 0 respectively. Now I have plotted the graph between x and the cos of x. Yes, the graph is also so like the sine curve, but the hint is that it does not pass through the origin. We can easily conclude whether it is a graph of cos function or cosine function. Function by saying that whether it passes through the origin or not. If it passes through the origin, then it is a graph of sine function, while if it does not pass through the origin, then it will be the graph of cosine function. It is an easier way to remember the graphs. Now again, the period of cosine function is also 2 pi like the sine functions. It gives the same values for the increase and decrease of 2 pi. I have demonstrated it from the example that if we put cos x, then it gives the same value as if we put cos x plus 2 pi. For example, cos 30 gives 0.86. Similarly, cos 30 plus 2 pi, that is cos 390 degree, also gives the angle of 0.86. So its period is 2 pi and it repeats the value for the addition of 2 pi in the circular measure of the angle. Okay, now the third type of function include the tan functions. These tan functions are represented as y is equals to tan of x. The domain of tan functions is sometimes more confusing for the students. Actually, we know that tan is equals to sine over cos. So all the numbers on the real lines where the cos is 0 is not included in the domain. If we put cos x, if we put cos x is equals to 0, then it will become the infinite value, which is inconsistent value. So the domains include all the set of real numbers where x is not where cos x is not is equals to 0. We know that cos x is 0 in the odd integral multiple of 90 degrees. So the domain of such functions include the set of all real numbers where x does not belongs to the odd integral multiple of 90 degrees. These odd integral multiples are represented by 2, 1 plus 1 pi by 2. And the range of tan functions is from minus infinity up to positive infinity. It can give the value of it can give any value on the number line. And okay, now the graphical representation of the range on the number line is shown below. It shows that it gives all values from minus infinity up to positive infinity. Now again, it is important to know that the tan function is positive in first and third quadrant, so it gives the values from 0 up to positive infinity only in from first and third quadrant, while in second and fourth quadrant the tan function is always negative, so it gives the values from 0 up to negative infinity in second and third quadrants. Now the graph of tan functions is represented below. If you put x is equals to 0, then value of tan function will be 0. Similarly, if we put x is equals to 30 degrees, 60 degree, 90 degree, and the value of tan functions will be from 0, 0.58, 1.73 and positive infinity. The graph of tan functions is represented in the side figure. It shows note that the graph of tan functions passes through the origin, and moreover the period of tan function is pi. Unlike sine and cosine, it gives the same values for the addition of every pi in the circular measure of the angle. We get the same values of the tan functions if we put tan x and tan x plus pi. if for example we can demonstrate it that if we put tan 30, then it gives a value of 0.58. Similarly, if we put tan to 10 degree, then it also gives the value of 0.58. So it gives the same value for the addition of every pi in the circular measure of that angle. Thanks for watching this video. If you find this video informative, please consider liking, sharing and subscribing to the channel for more videos and updates. Your support is greatly appreciated. Moreover, if you want to deliver the lecture on some specific topic, then kindly write it in the comments. Thank you.